So I'm going to pass it back to Steve Getz. We're going overtime on this, but I hope everybody's staying with us. Let me see if I can get.
Okay, where is the geothermal industry going to go in the 21st century? Let's just take a look at it here. What are the factors that are really determining the industry growth? Big one right now is perceived climate change. You see, people believe there's existential aspects of which create political aspects. Consequently, fossil fuels have become out of favor. Plus, you have global economic factors. Some places actually have geothermal that don't have any oil and gas. So it's an interplay of those two items. So let's take a look at the first one, climate change factors, the existential aspects. It's perceived, potential climate crisis perceived by some people to be the biggest social, political, and economic environmental problem facing our planet and its inhabitants. How you look at it. People are becoming increasingly aware of this. Is by the second one down here is Jerusalem Post quote, becoming increasingly aware of and concerned about the climate crisis and its consequences, despite corporate misinformation and some media obfuscation due to frequent reports regarding record heat, droughts, wildfires, and increasing number of severe storms and extreme weather events, melting the glaciers. About 80% of the world's glaciers are rapidly shrinking. I don't necessarily believe that, but a lot of people do, and it's creating problems, especially the Democratic Party. The political aspects, perceived climate change have caused people to alter their overall usage of fossil fuels. Governments have passed laws requiring environmental pollution are now requiring changes to fossil fuels. And as Bob said, there's some companies that have big fields are not getting any money to develop them, even though they've drilled their outposts well to know the size of the field, because they're having big problems in Europe getting funded to get the field developed, and they have some problems in the United States. So it really comes down to this. The government taxing authorities award tax deductions for non-fossil fuel machines, okay, which is geothermal. Banks are doing fewer loans for fossil fuel development, as I said. From 1980 to 2020, extreme weather cost $1.8 trillion, causing insurance companies to raise their insurance rates in vulnerable areas. And this is interesting here. I never really, until I really studied this, I didn't know. Climate change creates mass migration around the world, while these people from Africa are moving north into Europe and from the Middle East. That's part of the reason. People are leaving flooded coastlines, drought-stricken farmlands, and areas of extreme natural disasters. Just in the 10-year space from 2008 to 2018, events related to climate change and weather displaced 22.5 million annually, according to the United Nations High Commissioner for Refugees. Some forecasts predict that by 2050, climate change could cause as many as 1 billion people to immigrate. That's 13%. As America experiences more extremely hot days, food prices are rising. Corn and soybean yields in the United States have precipitously plummet when the temperatures rise above 84 degrees Fahrenheit. Those crops feed the cattle and other meat sources, create spikes in beef, milk, poultry, and poultry prices. Worker productivity declines sharply, particularly for outdoor jobs. That further increases the cost of food. Here's my own map. Bob had one similar, but I've kind of modified it to kind of see what's really going on in the geothermal resource United States. And what you can see, the geysers sit over here. Now, they sit kind of at the end of the San Andreas Fault. And I think I've got a slide that comes up and shows that. But right where the geysers is, you have the Mendocino fracture zone that comes onshore. It goes right through here. And this western side of California is moving to the north here, and where by strike slip sands. And where the strike slip fault ends, you start going into the subduction zone. You get up in here around the Cascade volcanoes along the Mendocino fracture zone. If you bring the Mendocino fracture zone through here, it almost goes into the Humboldt fracture zone up in here. And basically, that's where the Yellowstone hotspots kind of really migrating along that that rift, that major pull-apart zone in here. Of course, right along here, remember, was McDermott volcano, and that's what gave you all these volcanoes you get up here in Oregon and Washington. Cascade volcanoes, again, when you go north of that Mendocino onshore situation, you get Cascade volcanoes. Starts, I believe, with one volcano down here, and it goes into Mount Shasta, and all these volcanoes in the Cascades in here. You get the Idaho Rift, Basin Range here. Not really been produced at this point in time. I've actually mapped this for oil and gas down here in southwestern Idaho. There's a gas and condensate play there. And you see most of the fields that exist now in Nevada are around Carson Sink. What's happened here, remember I showed there's an old elliptical dome that came up through here. And when the dome started to collapse, and I think we're basically in the late Rift Valley stage now. I don't think we're out of the rifting yet. We're late Rift Valley stage right now. When that dome collapsed, you had a huge internal drainage area in through here. The Humboldt River starts up in through here. It never makes it out of Nevada. It can't make it across the Sierra Nevadas. It has to end down through here in Carson Sink. And that recharge you're getting by water, because the water comes in along this river, it's a lot of water. It never makes it out of this Carson Sink. It just goes into the subsurface. At one point in time, Carson Sink here, this whole area up here was part of Lake La Junta, just like you had Lake Bonneville up in through here. You had Lake in this area through here. You had Lake La Junta out through here. You had a lot of subsurface water still in the system. But you're getting recharged by the Humboldt River and the Carson River coming out to the east off the Sierra Nevadas. It also extends down into the McGinnis Hills area down through here. There's a Humboldt shear runs through here, another shear, the Walker Lane shear, it bifurcates right at, part of it goes down through here, and part of it comes down through here in the Long Valley Caldera. This is producing geothermal heat right now in the Long Valley Caldera. And the continuation of this shear zone, or this rifting zones, goes down into Imperial Valley, where the onshore rifting you're having through here extends up and through here. So really, you have a rift up and through here, and you have a rift up and through here. Eventually, what will happen is this whole area to the right up here of the Humboldt and the shear over, the shear right here, Walker Lane shear, all this area will move relatively to the east. All this will move relative to the west. Once Yellowstone, the hotspot you have at Yellowstone volcano, eats its way through the continent, you get a separation zone all the way through. That's what will happen. It's really quite similar in many respects to the East African Rift Zone. Oh, down here you got a continuation of the Basin range structure, which is Jemez Caldera. It's very hot. I've been and seen those hot springs here, and I've been along the track and through here. When you go up to Gallup, New Mexico, first the oil and gas business back in the very late 60s, 1968, I used to see the fumaroles along the road through here. It comes down through here and comes into the Big Bend area down through here. But you also see as this goes to the north, you actually have very hot zones in Alaska, and you actually have a hot zone in Hawaii here. And actually, Hawaii is actually producing some geothermal energy off some volcanic vents there. So where is it? Where are we going in the USA geothermal industry? You're going to do extensions of the geothermal exploration of the Basin Range. It's going to go northwest into southeast Oregon, the Klamath area, the Alberta Valley area, north into southern Idaho, where you have the craters of the moon and in that area up through, and the north southwest Idaho Rift. East into eastern Nevada, Utah, and New Mexico, and that would be the Rio Grande Rift and Jemez Caldera. South along pull-apart valves from rifts from Long Valley to the Salton Sea. And they actually have right there, almost right at the shoreline, you've got Sierra Prieto in Mexico, which is producing geothermal energy. They've tried to do they actually have some geothermal plants around the Salton Sea. There's problems with the Salton Sea area because the rocks are just so damn indurated there. And you have a lot of bad stuff coming up out of the subsurface, which messes up your pipes. Emphasis on targeting blind or no active hot springs geothermal systems. For a long time, they felt if you didn't get a fumarole, you didn't get active hot springs right at the surface, you just didn't have a good geothermal system. So then they drilled McGinnis Hills, which has no active hot springs. It has some evidence on the surface where you have some geothermal, but not great evidence. So they drilled McGinnis Hill, and that's one of the best fields now in Nevada. It's producing a lot of megawatts of energy. McGinnis Hills is one of these situations where you get a accommodation zone and approaching rifts, and that's what, just like a Desert Peak field. Drilling deeper in rifts with no productive geothermal system, that would be Salt Wells Field. Salt Wells had some very shallow geothermal production and not addressed the deep production, and that's being addressed now by some other people, not us. Exploration of the Cascade Trend volcanoes in the Pacific Northwest. Mount Baker, Adam, Mount Rainier, Mount St. Helens, Washington State, and others. Newberry and other volcanoes in Oregon State, and Mount Shasta in California State. Remember, these volcanoes all end at the onshore extension of the Mendocino Fracture Zone, where things go from strike slip into subduction. Geothermal exploration in northern Gulf Coast onshore rocks, the Frio and the Wilcox, And is there other things to pursue? Yes, there are, and we'll see them. There's actually other geothermal exploration even in the Cenozoic rocks as you go towards South Texas. Mesozoic and Paleozoic rocks, and I say questionable Paleozoic rocks because it's question how much water you got in those rocks and how you can get the heat out. And Sabine and the Moreau uplift areas in Texas and Louisiana remain a very active high. It started coming up again in the middle of Cretaceous time, and it's come up also in early Laramide time. Exploration of West Virginia, Pennsylvania geothermal trends, we won't go into that much, but there's some real potential there. We have acreage there. Enhanced geothermal system, hot, dry rocks. This is the big one. Once you can get that to come in, that's going to really change things. Right now, we're at the stage right now when you're playing the Barnett Shale, where you can make money out of it, not a whole lot of money. You're going to have to figure out the hot, dry rocks. Once they do that, and the DOE will be involved with that, and they'll probably fund part of that, then geothermal will really take off. Right now, there's a lot of potential left in without being enhanced, just conventional geothermal, but that's the big one, and that's coming. Use of geothermal fields for TEOR is supposed to be green. I don't know how it shows up in your thing. You can actually use the geothermal fluids to steam clean the rocks of the areas around the pore space. What you're doing, you steam clean the rocks like a steam clean carpet. And you also have possible hydrogen production, so we'll discuss that. Now, here's the exploration of the Cascade trend volcanoes. I showed you another slide. Here you can see the Mendocino fracture zone really comes right through here. The geysers sit right in here. You can kind of see that the strike slip for the San Andreas comes up through here and just kind of disappears into the Mendocino fracture zone. Mount Shasta, that little white thing, that's Mount Shasta up here. Mount Rainier sits up in here. Seattle sits up in here. The area you see here is actually a non-volcanic outer arc. This is the inner volcanic arc. Then you kind of see these things look like migrating worms over here. This is the Basin Range province. It comes up through here. It comes up into Idaho, with mainly covers most of Nevada, and it comes down into southeastern California. And you get an idea over here where the Pacific volcanoes, remember I said it didn't stop right here, it keeps going up into the Pacific Northwest. There's just not that much population up there to want to use it. Again, there's Mount Rainier, Mount St. Helens, Mount Adams, and there's those other volcanoes up here with good potential. It goes all the way down into here. Again, Mendocino fracture zone comes up through here. So we go on, see if I can click on this thing. Okay. Again, take a look how big this Bacon Range province is. Here again is the area around Klamath Falls, the Alvord Valley area up in here. It goes up in an area around Salt Lake City, all the way down through Nevada, through southern Arizona, into New Mexico, all the way down, follows the Rio Grande Rift. It's real hot there. It's been hot there even in Oligocene time, all the way down coastal Mexico. And you go over here, you can see an idea on the right. Evolving plays up here in the Klamath area, Alvord Valley area, southwest Idaho Rift area, up around the craters of the moon. Evolving plays up here in northwestern Nevada. There's plays there. There's not been addressing them that much. Evolving plays are in northeastern Nevada, eastern Nevada, western Utah. The evolving play down here, right through here, is kind of where McGinnis Hills is. So you get an idea that's not a bad play to make. They're going to these areas that don't have the obvious hot springs on them. Then down through here, you got the expanding play. Remember, this is this Long Valley area. It goes all the way down through to all the way down through southeastern California. That's going to be the Salton Sea, with the remnant of it. Remember, Cerro Prieto sits right in here. And then you got an evolving play over here around the Rio Grande Rift. Eventually, that's what's going to provide a lot of energy for New Mexico. Okay, I get back to this where I talked about the emphasis on blind systems, blind geothermal systems where you have no active hot spring. And there are none at the surface here. Remember how I told you there was a transverse feature here. Notice that these faults are all going down to the southeast. These faults are going all down to the southeast, well, northwest. So when you do that, you get an accommodation zone high right in here. And just like Desert Peak Field, this is a major geothermal field. Here's what you're looking at it down here. This is kind of the idea that you're looking at accommodation zone overlapping the opposing normal fault system. This would be McGinnis Hills, would also be Desert Peak. And these are basically two different cross sections. There's nothing that designate what things were up in here. a little bit thinner, hard putting designations up here. This is andesite and dacite through here. You can see the dikes coming up and feeding them right in through here. And that's your geothermal field. It's very close to the surface. You don't even have to drill 3,000 feet to get very hot rocks down up around 350 to 450 degrees out. I mean, it's a very good field, very profitable for Ormat. Okay, now we'll go into enhanced geothermal system exploration, EGS. We'll look at this down through here. They're working in the area around Soultz in France, and they're looking to try to make money off these hot, dry rocks up in here. And remember, this is still in the nascent stage. This is the first enhanced geothermal test sites near Soultz. It's already online. If it goes well, the EGS can be fused with potential to produce 10% of our nation's energy, our nation being the United States, not there in France. The speed uplift area of northeast Texas, northwest Louisiana, and southwest Arkansas may be a viable target for EGS. I think it's a very good target for it. So I'll go back up to here. And remember, I told you the DOE are working with us to get this electrical from the hot, dry rocks. Remember, that's what DOE did to the Barnett Shale. Now, DOE comes in and helps fund things. They actually helped fund the first commercial geothermal plant in the Frio system there in Brazoria County. But as soon as they start to make money, they step off because they're not supposed to be making money. They're supposed to be helping people who are businessmen in the United States make money by doing some of their stuff, working with geology. So anyway, their strategy is still experimental, is to pump water in the hot basement rock. That's deep crust rock that lacks permeability, creating new fractures and opening and widening existing fractures. It's a form of natural fracturing. It's not fracturing. You're not taking a whole bunch of sand and shoving it down the hole and under a lot of pressure to break up the rocks. You're not doing that. Now, once they get the fractures open, the water's pumped into the wells. And this is what happens naturally at the geysers. Unfortunately, the geysers, they sucked up a lot of the water out of the geysers. They're having to re-inject it now. So that's pretty much that. I'm going to go on here. Now you get an idea of the geothermal exploration in the northern Gulf of Mexico, Gulf Coast onshore rocks. Here are your, right about here, you run into your Eocene Wilcox rocks. These will be your main classic sequence that came off the Iranian Revolution. When you push up the rocks in the Rocky Mountains. A lot of that sediment came down and gave the Eocene Wilcox. And then the next big system down here is the Oligocene Frio. Between them, you get the Yawa. It's also a decent system. I think there's potential in the Yawa, especially in these blocks over in here. Then you got the Sabine uplift over here. You notice the temperatures versus depths. The depths of the squares are 400 to 450, and that's what you're really looking for. But you'll take 300, 350 plus. You'll get it down here in Brazoria and Matagorda County through here. And look at the depths are actually color-coded, 13 to 14,000 feet here, 18 to 24,000 feet here. You can kind of see this is stuff down here is going to be anywhere from about 16,000 all the way to 20,000 feet down through here. That creates its own problems because you have to have very big pipes to produce this stuff. Bob was saying you can make money on 20,000 barrels water today. You can't, but it's a stinker well. You want 50,000 barrels a day, and a really good well is going to produce 100,000 barrels a day. When you start going to 100,000 barrels per day production, you're going to have some very big casing systems going down to where you want to perforate the rock. Also, you're not going to do that with a vertical hole. You have to go directional. I don't see another way to do it. Remember, that's what made up in this area up in here, what made the Barnett Shale so profitable. They started going directional and doing their slick water fracking and going directional. Now you go over here and you see the heat over here. This is 150 Fahrenheit here all the way to 350. Some of this gets almost to 325, 350 F in here. Sabine uplift up here, which we know is a very, it had a lot of uplift all the way up into Oligocene time, as I remember, big uplift in Laramide time. But you see all this area is hot up in here. By the way, these little dots here, these are places where they have a geothermal gradient wells, where they have bottom hole temperatures and they can measure them correct for them. Go on. And this is what probably half the people watching the show want to know is what employment opportunities exist in the geothermal industry. The industry employs geologists, geophysicists, engineers, and landmen. It should sound very familiar to you people. Geothermal fluids are pooled in hard rock reservoirs, mainly hard rock in the western part of the United States, which would be Nevada and California. And the reservoirs often include intrusive and extrusive rocks, such as fractured granites, rhyolites, diorites, and even basalts. So like the mining industry, the geothermal industry often hires geologists from hard rock colleges. For all you people that came from hard rock college and you're despairing because you're doing nothing but sedimentary rocks, then you come back to geothermal, you'll be back in hard rock, except you don't have the danger of going down into a deep mine. However, some fields are pooled in sedimentary rocks, and this is still to be addressed, and this would be the Wilcox and the Frio, possibly even the Iowa, and the area to the west down there in South Texas. Sedimentary rocks there. I think it's a couple thousand megawatts going to come out of these sedimentary rocks. Geothermal fields often have surface manifestation, hence geological work usually includes surface mapping in the field. You people just despair because you sit in the office all the time. You get into geothermal, you're going to go out in the ground. You're going to see the geothermal. You look for the manifestations. In the Basin range, you got the horse and the grabens, which are the ranges and the sinks, like Carson Sink. And you go out there and you surface map all this stuff. In a way, you can surface map the hot rocks and nothing else just by comparing Landsat photographs. When you go to an area that's got very hot surface rocks, it melts snow. So you pull up a Landsat map the day after the snow, and you'll see there's no snow in some areas, and those are the hot areas because the ground surface there is probably up around 90 to 100 degrees. Engineering jobs include drilling engineers, mechanical engineers, as well as reservoir and production engineers. Fracking is not usually done in geothermal development. Mechanical engineers are mainly the people that construct the plant. Drilling engineers, you still need drilling engineers. You have to reformat yourself for what you're doing here in geothermal, but it's still drilling engineering. Reservoir and production engineers, again, you have to kind of reformat yourself for the kind of reservoirs you have here because you're not dealing with typical sandstones and carbon. It's different. Not impossible, just different. You're going to have to be clever about what you do. Good landmen are also needed, and they're very much needed. In the western part of the United States, you're dealing with checkerboarded BLM land, so half of that's taken by the government. You have to deal with them. But the other half is usually very big ranches, and they're good places to go, and landmen can deal with the ranchers, just like you did in South Texas. Questions? That's kind of the end of the presentation, people.
Yeah, Steve, I got some questions that were submitted during the talk.
Okay.
So the first one is, how do you see the role of geologists in future geothermal industry? Are jobs going to be few and far between? Is it simply drill a few wells and then the project is done? Or do a sufficient number of wells need to be drilled for a project that may ensure more long-term employment?
Good question. Some geothermal fields end up being a lot bigger than what people suppose, and some geothermal fields end up being a lot smaller. It's like drilling for oil and gas. You have a lot of data to deal with. You have gravity, you have magnetics, you have some seismic, but seismics, if you work in the Gulf Coast, it's great. When you get into Nevada, some areas around Washington, Oregon, it gets to be kind of scary because you have these volcanics that speed up the seismic as you're going down into the ground. I think there's potential for geologists to come into our industry. We're a startup company right now, and we'll be looking for geologists probably in the next about 2-3 months. Right now, Bob and I are pretty much handling it, but we can't do all the field work that needs to be done. We're going to have probably multiple rigs running. I'd say at least 3 to 5 rigs running on different prospects in different areas. And when I say prospects in different areas, some will be in California, some will be in Texas, some will be in Oregon, some will be in the Arklatex area, and all the way down to the Gulf Coast. So we can't do all that ourselves, so we'll be hiring people. Some of these people will come out of school, and some of these people will be people who are already existing in the industry. I hope that answers this question.
Okay. In terms of limiting factors for geothermal prospectivity, is reservoir quality more important than high downhole temperature? Is it possible to apply a frac to tight igneous rocks to replace a fractured basement reservoir?
Temperature is the big thing because you have to have the temperature. Permeability is another thing, and that's where the system falls down. Your main delivery system for your areas around Nevada is the fault itself. You drill into the fault, you start producing the fault. And your support system is all the stuff that's coming up from the fault. Some of it's sedimentary, most of it is just fractured basement. And when I say fractured basement rocks, it could be thousands of feet of fractured basement. And at different points of time, these basement rocks, back when you had your beginning of your pre-rift, this was all exposed. You get a lot of karsting along those old fracture zones, and they give you permeability fairways to the borehole. But also, you get an area of eroded granite right along that surface. It becomes a reservoir. But your reservoirs are a combination. I'd say in the Basin range, I'd say about 3/4 of reservoirs are going to be basement or rhyolites or dacite and whatnot, or even basalt sometimes. When you get into the Gulf Coast, I'd say it's mostly going to be sedimentary rocks. I'd say it's going to be carbonates in the area up around the Architects area. You get down to south upper Texas Gulf Coast, it's going to be mainly sedimentary rocks. Thick sedimentary rock sequences or deltaic.
How do mineral and royalty interests apply to geothermal?
They're different. You don't get, you pay the landowner, you don't pay them nearly what you pay for oil and gas. The good oil and gas province, you'll pay anywhere from 70 to 80% royalty, and the average maybe 75. But you go to geothermal, if they get 1 or 2%, that's a lot. Because remember, you can't be paying big royalties like you do in oil and gas to the surface or the mineral owners, and they realize that.
Is there a potential for geothermal related to supervolcano in the Aleutians?
Supervolcanoes, actually Yellowstone's a supervolcano. The problem with the supervolcano is you don't want to set that little devil off. If you do, whatever you get out of the way in geothermal energy, it would really hurt mankind a lot. So you drill around the peripheries of those zones, but very, very carefully. So we're not really drilling so much supervolcanoes, we're drilling individual volcanoes, the flanks of them. We had an opportunity to pick up acreage around Yellowstone, and we just kind of shied away from it. For what I just told you, we were just afraid that we would get some kind of chain reaction we didn't expect that would cause us problems. And as people slowly creep into these supervolcanic areas, they'll understand the limitations and they'll feel more comfortable doing it. At this juncture, we don't want that kind of problem to be associated with it, so we stay away from that. But I think it's a good play.
Okay. Can you comment on the proximity limits to population centers required for geothermal development? Does it make sense to develop some of these areas in really remote regions?
If it's too remote, that's problematical. You look at Nevada and California, you've got a lot of power lines that crisscross Nevada and California. You wheel the power from Nevada into California. They really hurry for power. In fact, right now we didn't show the slide that showed that, but in the year 2020, which is this year, they're supposed to have 1,500 megawatts of non-fossil fuel power. That means it's not coming out of oil or gas or coal. It has to come from that. 1,500 megawatts is a lot of power. Distance to existing conduit or high wires, it's important. It's not the only thing, but it's something to consider. And as things start creeping out, it's like production of pipelines and fields for oil and gas. As you start building infrastructure, some things that weren't coming into play before now come into play. Does that answer your question?
Yeah. Another thing is, the other question is, how effective is magnetotellurics in detecting potential geothermal locations?
I would say it's pretty good. I know the ORMAT's using them a lot because it detects, I believe, water really good and other things. I've not really gotten really good at it, so I can't really comment other than that. I know the people who are doing geothermal in a big way, and ORMAT is that company in the United States, are using magnetotellurics. We will use it also. But we'll also use gravity, magnetics. We'll use seismic, although limited. We'll use seismic in the areas where we want to actually drill wells. We want to pinpoint that fault, nothing else. But also you can see some other things on seismic you wouldn't see with just gravity magnetotorcs.
Yeah, okay. Well, we've had a lot of questions so far. I got one more for you.
Okay.
What legislation to enhance geothermal fiscal terms do you see coming from the new administration?
Well, Biden's in. I presume Biden's going to sustain himself. He's got 2 electoral college, although Trump's his nemesis. I think Biden will sustain himself, and he will be the next president. He's president-elect right now. He's really coming down on oil and gas and coal. He's really going to pile a lot of money into renewables. It's going to be solar, it's going to be wind, and it's going to be geothermal. We're going to get a lot of money off geothermal. One of our biggest acreage holders right now is a company that has a lot of coal acreage and a lot of oil and gas royalty acreage. And they're going to probably end up helping, I think they'll end up helping fund us, even though we got a lot of their acreage, because they see the handwriting on the wall. People, it's the geothermal and other methods are going to be the future. Solar can only get you so much. Geothermal is baseload power. Solar's not baseload, wind's not baseload. Oil, gas, and coal are baseload. I don't think gas is going to go away for a long time. It actually burns pretty clean. But also, you can actually, in some areas where you don't have the high wires, you can actually build a hydrogen plant there, and truck out hydrogen. So there's all kinds of potential on a green sense for geothermal. Geothermal, I think, is not really taken off in a big way, but I think it's about to explode.
Well, I appreciate that. We got one more last minute question, so I think I'll just throw this one out there too. What royalties, or would royalties apply to simple barrel or produced water or cubic feet of steam?
Let me answer that, because basically the royalties are paid on the electricity produced.
Okay, so probably more related to steam.
We're looking at this as electricity, so there'd be an override on the electricity.
Okay, that makes sense. Well, just to respect everyone's time and to respect y'all's time, first of all, the Houston Geological Society would like to thank you both, Steve and Bob, for taking time out of your day to share this information. It's very exciting information. I think it's necessary to generate some of these talks now, especially in the geothermal with all the changes happening around us. So thank you so much for that. Very interesting talk. We'll be sure to follow up. If you have any questions, anybody else have questions, please send them to the HGS office. We have no problem facilitating further discussion around this. But with that, I just want to thank you guys. I appreciate it.
Okay.
You're most welcome. I hope people stayed with us.
No, you had a good crowd all the way to the end. Just one thing. What was the name of the company that y'all are working for?
Our company name is called Green Cloud. We're not
Green
listed
Cloud?
yet. Green Cloud. We're actually trying to get funded right now. I'm pretty sure we will in the next 60 days.
Okay.
Well, very high power people. A lot of people with money are really looking hard at us because of the situation going on right now.
Because you're there, Steve.
No, I don't think so. I said this on the first show, and I'll say it again. When I went into geothermal, my 2 sons were both in oil and gas. Dad, why are you getting into geothermal? And I said, it's the future. Dad, you're in your late 60s. What kind of future you got in geothermal? I said, I didn't say my future. I said, the future. I think that's what's got to happen. On a global basis, we got to access that Earth's heat. So the future is in geothermal in my mind. Solar will take you so far, and so will wind. But it's not baseload power, people, and you're going to eventually run out of oil and gas.
It's decarbonizing the energy system. What is it? So decarbonizing the energy supply chain. That's a good buzzword for it. And based on this idea of externality accounting and the potential harm of the rising temperatures and CO2 in the atmosphere, the strength of
All right. Well, We appreciate y'all's input, and we thank everybody else for attending. So with that, I think we're going to go ahead and end the webinar. So thank you so much once again, guys. We appreciate it.